Jai Hind dear students, welcome back to this video. In this video we are going to learn about different properties of square numbers, and trust me, they are very interesting. So let's get started. Now let us learn some interesting patterns in square numbers. Do you know the patterns shown above? These are the triangular numbers whose dot patterns can be arranged as triangles. Now we are going to combine two consecutive triangular numbers. Now we are going to add 1 star to 3 star. We will get 1 plus 3, that is 4 star. Then adding 3 stars to the next 6 stars, and then we will get sum as 9. Again we are going to do the same, adding 6 stars to the two next consecutive stars, and we get 6 plus 10, that is 16, square of 4. Then again adding 10 stars to the next consecutive 15 stars, we will get 25. Now tell me, do you observe anything special about this number of stars? Yes, see the patterns in the square numbers. Now let's see the multiplication grid up to 100. Now we shade the square numbers like 1, 4, then 9, then 16, 25, 36, 49, 64, 81 and 100. Now tell me, what do you observe? Again, have you observed any pattern here? Think about it. Yes, I think so you got it. You are right. All the diagonal numbers are square numbers. Yes? So now, if we will find the difference of square of 1 and square of 2, we are getting 3. Now count the non-square numbers between the non-square number 1 and 4. So there are 2 non-square numbers. Now find the square of the difference of 2 and 3. So on solving we get 5. Now count the non-square numbers between the square of 2 and square of 3. We will get 4 non-square numbers. Again, if we will find the difference of square of 3 and 4, we are getting 7. And on finding the number line, the non-square numbers between 3 square and 4 square, we are getting 6. Now tell me again, do you see any patterns? Now observe the difference of the square of any two consecutive numbers and the count of non-square numbers between them. We find the count of non-square numbers is 1 less than the difference. We can generalize this pattern. In finding the non-square numbers between two consecutive numbers, let us consider n as any natural number. Therefore, its consecutive number will be n plus 1. And the difference between them will be n plus whole square minus n square, and we are getting result as 2n plus 1. So in this way we can find non-square numbers between two consecutive square numbers. Now let us see stair-step pattern. Now tell me, do you observe any pattern here? Now consider the following. The square of 1 is 1. Then the sum of 1 plus 3 is 4, which is again a square of 2. Then the sum of 1 plus 3 plus 5 is 9, which is a square of 3. And in last, when we find the sum of 1 plus 3 plus 5 plus 7, we are getting 16, that is square of 4. Now again, if you will observe the pattern in the left hand side, we are getting sum of odd numbers. and on the right hand we are getting the square numbers. On this basis, we can say that we generalize this result as the sum of first n odd numbers is n square. Clear? Now, moving further, let us consider the following. If you will see, on the left hand side, we can express the square of odd numbers as the sum of two consecutive numbers. But how we will find? Now the main part. We will find these consecutive numbers by subtracting 1 and divided by 2. For the second part, we will get adding 1 and dividing by 2. Clear? Now let's take the square of an even number and let us try to find the consecutive numbers. We will find that we are getting result 5 over 2, which is a fraction number. It means that we cannot find for an even number. It means that we can express the square of odd numbers as the sum of only two consecutive numbers. Now let's study one more pattern. Do you observe any pattern over here? First of all, in the right side, the number of digits in the product is odd in number. Since the digits is odd, so if we will select the middle digit, then each side will contain even number of digits, and those numbers are in reversed symmetrical order. So these are some patterns shown by the square numbers. Now see this pattern. How interesting square number patterns are, right? So let us learn some more interesting patterns based on this. Now let's learn these patterns by taking an example. So first, if I say what will be the square of 1? So what you will say the answer? Yes, 1 square will be 1 only, right? Now, if I write 1 1 or 11 square, or I can write 111 or 111 square, or 4 times 1, then in this pattern we are taking only those numbers which are containing 1 in it. So now let us take 4 times 1. Again we are taking 5 times 1. Now suppose in general if you find the square of these numbers, it will be very hard. Let's take 6 times 1 also. Now to find more patterns, it is very important to understand that what is the concept behind the answers. Like if I find square of 11, then it is 1 to 1. It means that the middle number is being added. So 1 square is 1. So 11 square will be 1 to 1. Understood? And so what is the concept behind it? First and last will be the same, but we are going to add 1 in the middle part. Okay? See, 1 2 is the mirror image of 2 1, and in the middle 2 we have added 3. Likewise, if we do again, then 1 2 3 4 3 2 1. And for 5 times 1 square, it will be 1 2 3 4 5 4 3 2 1. Like this. Okay? And for the 6 times 1 square, what it will be? 1 2 3 4 5 6 5 4 3 2 1. I hope so you have understanding what is the concept behind this pattern. Okay? If you have not understood, so let us take it one by one. What is the concept behind this? It is very important to understand this, that if we have any pattern, any kind of pattern, then we have to search the concept that in which way we are getting the result of the numbers on doing the squares. So in the first row we have only ones, so I'm writing 1. In the second row we have ones, tens, so 2. Third we have 3, 4, 5 and 6. Clear what we are doing? Now if I do square of 1, we will get 1 directly. 1 times 1 is 1, so we are writing 1. Now for the second ones and tens, from the second row if I talk, if I do square of 11, then what is the pattern? Just double the middle one and write 1 1 each side. Okay? For the third row, what we are going to do? In the third row, we have 3 ones. So we'll write 3 in middle, and left and right will be the previous middle part, and then 1 1 in last. Okay, you can take as a mirror image also. Now in the fourth row we have 4 ones. So what we are going to write, we will write 4 in middle, then the previous middle will be the both sides, or you can write the mirror image also. Clear? So your answer, your final answer will be 1 2 3 4 3 2 1. Right? So for the 5 times 1 we are going to write 5 in between. Previous between will be both sides, will be present here both sides, 4 4, or you can go in a descending order till 1. And in the left side you can write the mirror image or go in the reverse order till 1. Now I hope so you can easily do for the 6th row. What we are going to do? Directly we will write 6 and then right side we will go in the reverse order till 1, and of course in the left side also we will go in the reverse order till 1, or you can write the mirror image also. And in this way we can easily find the square of this much big number, right? So at this point I can say this is really a very interesting pattern. Till now, if you haven't understood it properly, don't worry. Let us revise one more time. So what we need to do, whatever number of times of 1 we have, like here we have 6 times 1, that number should be in, like 6 is present in middle of the part. So that is very important to check out that the number of ones we have, that is present in the middle part or not. And after that go in the reverse order till 1 in the right side and write the mirror image to the left side, or you can also in the left side go in the reverse order till 1. Left and right both side except the 6, suppose 6 is a mirror, so left and right both should be the mirror image of each other. Okay, so this is the main thing. The number which is in between, that number will be the number of ones, that how many one we have. Clear? So students, think about it. If you need to find the square of this large number, practically it will take so much time, but on finding the pattern of this, it become more easier. And also you have to think that why this pattern is becoming, for every question think about it, that what we have done, what happened that we are getting this kind of pattern. And also try to find more such kind of patterns, except your NCRT, except what we are discussing over here. We have discussed the same, I think so, yes. So except that you have to think about more such patterns. It will only increase your mental ability, and that will be so good, right? So we can easily find the square of any number if the number are in this pattern. Okay, you can try it for 2. As 1 second you will find the answer that 22 square is 484. How interesting is this, right? So let us move to our second pattern. So as we have learned that if the numbers are in some kind of pattern, then only we are able to find the square of that number. So let us check for 7. If we are having 7 square, you will get 49, right? 7 times 7 is 49 only. Now suppose that if we are having number 67 and need to find the square of this number. So before proceeding further, let me tell you this pattern will only be applicable if we have 7 at our unit place. Now let's start learning this pattern. So first of all you need to count how many number of digits we have for which we are going to find the square. Here we have 2 digits. It means that we will get answer of 4 digits. We are just going to do the double of it. Okay, so that's why we have made 4 places, as in the question we have 2 digits, and on doubling we will get 4 digits as our result. Now at the first and second place we just need to write 4. Understood? Suppose if we have 2 digits in our question and in the answer part we are going to have 4 digits, right? So in the first 2 places we are just directly write 4. Let us do it half. suppose whatever the number you have, if we will do it half, so at the first two places from the left we will just write 4. Okay. Now to fill the last place, what we are going to do, whatever is the rightmost squares, we will write that. Here we have 9, so we will write 9 at the rightmost place. Understood? Now whatever will be the vacant places, there we will write just 8. Understood? Now you will think that what interesting in this pattern or in this squaring, but trust me, this is very interesting. Like if you will find the square of 3 numbers having 7 at their unit place. So let us take 667 square. It will be very easy for you to find the square of this, and in practical way this will be so difficult as we need to do the multiplication, so long multiplication. So what we will do, here we have 3 digits, so in answer we are going to have 6 digits. As I told you, we just need to double it, whatever number of digits we have in the question. Now half it, as I told, after doing half, in the leftmost we fill it by 4, right? And what to do next? At the rightmost place, that is your 6th place from left to right, if you will count, you just need to write 9, right? And in the vacant places, whatever places are left, just fill it up by 8. See how interesting it is? It just hardly took 2 or 3 seconds, I hope so. So now try it by yourself and see you are able to do it or not. So for right now, to making this thing more interesting, let us take 4-digit number. Okay? And in answer part, if we have 4 digit in question, in answer part we will get 8 digits. Now I want to tell you one thing, that please try it by yourself once, then only you will get the better understanding of this concept. So if we have 4 digits in question, then 8 digits in answer part. So, and after that, draw just a small line in between so that you can easily divide 4 left sides and 4 right side places. Okay, now fill up all the left side places with 4 and right side rightmost place with 9 and the left places with 8. See how easily we have found the square of this 4-digit number, and we have used the same algorithm that we have used in the squaring of 67. Now let us take one big number so that your concept will be more clear. Now suppose here we have 5-digit number. Now one important note, that this will only be applicable when you are increasing 6 and 7 will be present at end or at the unit place, then only we can use this rule. So now here if you will see, here we have 5 digits, right? So if we are having 5 digits, so in answer part we are going to have 10 digits. So let's make 10 places for that. After making 10 places, just we will split it from middle. Okay, so at the first 5 places, starting from 1 to 5, we are just going to write 4, right? At the end we are going to write 9, and in the remaining places write 8. Clear? So in just 3-4 seconds we have found the square of such big number. Now let us check for 6 digits number. Now what you have to do, pause the video over here and find your answer, then see the result. Okay, so if we will continue it, we will make 12 places. Why? Because we have 6 digits in our number. So in the first 6 places, simply we are going to write 4. Okay, and in the last we are going to write 9, and the rest places 8. See how easily we have found the square of such big numbers using some interesting patterns only and some rules. So it is more important now to do practice by yourself. If you will do practice by yourself of such patterns, you will be easily to do such type of squarings in just 2 or 3 seconds without using pen or paper. So it is very important to do practice. Try to make your learning more effective by doing practice, as only practice will make you more perfect. I hope so you have understood these concepts. I tried my best to make you understand related to all the properties, and I hope that you have understood it also. So we will learn more about this chapter in our next video. Till then, take care and thank you.